Hello, everyone. I'm Dr. K. Swag, Associate Professor in Department of Computer Engineering of AISSMS Institute of Information Technology, Pune. Today, I'm going to explain what is virtual function in C++. Before going to details of the virtual function, we must know the polymorphism and types of polymorphism. We know the polymorphism. Polymorphism means many form. There are two types of polymorphism. One is a compile time polymorphism, and other is the runtime polymorphism. Compile time polymorphism happen through function overloading and operator overloading, and runtime polymorphism happens through the virtual function. Runtime polymorphism through the virtual function. Compile time polymorphism is also called as a early binding, or it is called as static binding also. But runtime polymorphism also called as late binding or dynamic binding. Now we are going to see in details of the virtual function. Virtual function is looks like the same as a normal function. When virtual function accessed in a program, normally it behaves just like any other function in a class. But when it is accessed via pointer, the most important here is when we access via pointer, it supports runtime polymorphism, and we are going to see in details when we access through the pointer and how it supports the runtime polymorphism. Function are declared with a virtual keyword, or just virtual keyword is append before the function. That function become the virtual keyword in a base class, and this is in a base class. A virtual function is a member function that is declared within a base class and is redefined or overridden by a derived class. Means the same function is declared in a base class as well as in a derived class. Means as we learn the operator function overloading, in function loading the name of the function is same but the parameters are different. But in this case, in a base class as well as derived class function have the same parameters and name of the function also same. When you refer to a derived class object, or when we create the derived class object using a pointer or reference to the base class, or we are trying to access derived class object through the base class pointer, at that time you can call a virtual function for the object and execute the derived class version of the function or proper function of the object. Why virtual function is important? Virtual function ensure that the correct function is called by an object. If we are not using the virtual keyword, your compiler not access correct function, it will always access the base class function. To avoid the execution of wrong function execution, we are going to use the virtual function, regardless of the type of reference or pointer used by the function call or used for the function call. They are mainly used to achieve runtime polymorphism or virtual. When you added the virtual keyword in front of function, this is mainly to achieve the runtime polymorphism. We are not using, it is the your compile time polymorphism. Resolve the function call at runtime. Rules for the virtual function. These are the some of the rules. Virtual function cannot be static and also cannot be friend function of another class. This is the first rule. Second, virtual function should be accessed using pointer or reference of the base class. This is the most important, access using pointer or reference of a base class to achieve runtime polymorphism. The prototype of virtual function should be same in a base class as well as in a derived class. This is not the case of the function overloading. This is a case of virtual function. Mean base class function name and parameters is same as the derived class parameters. Then the function overriding is happen. They are always defined in a base class and overridden in a derived class. But it is not mandatory for derived class to override or redefine the virtual function. In that case, base class version of a function is used if it is not redefined. A class may have virtual destructor, but it cannot have a virtual constructor. Now we are going to see details. If we are not using the virtual keyword in front of keyword, what will be happen? Problem without virtual keyword. For example, base class and derived class have the same function name, and base class pointer is assigned address of a derived class object. Then also pointer will execute the base class function, not the derived class function. This is a problem here. We are going to see through the code. Here we have taken the one class or base class, and it has the function show, and it contains the base class. The definition or prototype of base class function is show. Then we have derived the class. Here is we have derived the class derived from the public base class. Now public void show. Public void show and void show both are the same, or you can say that is the overridden or same definition. Show with no parameter, show with no parameter. Now the role is here. When suppose we have created the pointer base star b, means we have created the pointer of base class, or base class pointer is created. Then derived d, we have created the one object of the derived class d. When we assign b, means pointer equal to and d, as we know the pointer, when we assign the point address of the anything to the pointer, that pointer pointing to the that object or that memory location. Now base class pointer pointing to the derived class object, but when we executing b arrow show, we are executing the b arrow show, we are telling here pointer to show function, execute the show function. But now in this case what will happen, actually the expected to execute the, because now your pointer pointing to the derived class, but it is expected to execute the this function or derived class function, but still your pointer executing or compiler or program executing the base class pointer. This is a problem. How to resolve or how to solve this problem? We have to add here virtual keyword in front of base class function. Now using virtual keyword, when we are adding the virtual keyword in a function, after making the virtual function in a program, the compiler will determine which function to execute at runtime on the basis of assigned address or pointer of base class. Okay, now here we are added the virtual keyword. Program is same. Now we move back to the here. If you just see here is early binding, and we know the early binding occurs means this is a compile time polymorphism. Okay, the question is here, the code is same. Everything we are using, even the base class pointer as well as assign the pointer to the derived class object. Still here is not happening the runtime polymorphism. Here is happening the compile time polymorphism. This is another difference. When without virtual keyword, this is the compile time polymorphism, not the runtime polymorphism. And the same code we have just added the virtual keyword in front of function, and all code is same as the previous. Only when executing this is happen here is a runtime polymorphism, and proper function or correct function executed, and it gives the proper output or correct output, derived class output. Thank you. Happy learning.